Hello, I'm Sri from CBTU. Welcome to another session on Java language. Section Java Basics, topic Java data types. Data types are the building blocks of any language. And Java also has data types of primitive type and non-primitive type. The primitive data types are basically the built-in data types, and there are 8 primitive data types supported by the Java language. They are byte, short, integer, long, float, double, boolean, and char. And the non-primitive data type or the reference type are string, arrays, and classes. And we have 4 integer data types. They are byte, short, integer, and long. The smallest integer type is byte, that is 8 bits in size. Short is 62 bit, integer is 32 bit, and long is 64 bit. And this is the range information. For byte, you say it's from minus 128 through plus 127. If you try to input 128 into a byte, it gives an error. And the default value for this integer types are 0. And we have 2 floating point number data types. They are float and double. Float is 32 bit and double is 64 bit. For float, you need to specify f. And the default values for the float are 0.0f and for the double 0.0. And the boolean data type is just 1 bit in size, and it can be either true or false, and the default value being false. And for the Unicode, we have char data type, which can take up to 16 bits. And this is the range, and the default is /u0000. The integer data type can hold only the integers, that is numbers. They cannot take floating point data like double or float. So you cannot use fractions with integer data type. And on the other side, double or the float can take the integer along with any fraction numbers also. We define variables in our programs. The data types are basically to set the size of that variable. If you want to use, say, number of months, they are 12 in number, and you don't need to use 32-bit integer type. You can use byte type. That can save a lot of memory. And if you want a large number, then you may go for the long. And if you want to use just true or false, then you may go for the boolean data type. The right data type helps us save in the memory that's being used by the program. The right data type helps us use minimum memory for our application. The char data type can take a single character, single letter. And the other data types we have are non-primitive or reference type. The string is sequence of characters in double quotes, whereas char data type represents a single character. Array is a container object which contains the value of a single data type. So you may have a container or a box. So it can be a string array which contains all the strings of information, and it can be an integer array which contain all the integer information in that. Class is a code template for creating objects. Class is the basic pillar for the Java language, and it's a blueprint for creating objects. Java string is an object to represent array of characters or simply text. So character is a single character within single quotes. And that character array defined here, if it's given to this string as an object, as an input, it creates a new string. We'll have more sessions on this string and string operations. Let us take a demo on data types. Let us comment this, take it down. Let us compile and run this. So here we have defined integer x initialized with 9. So x is data type integer. Because this is a small number, let us define it as a byte. Compile and see. The output is the same. So it can be short as well. Let us make it integer, and if I input with any fraction number, let us see what error it gives. The error is incompatible type. It's a compilation error. So let me make it integer again, number again. Let me define double D with input with 10. As we discussed earlier, double can take integer, but not vice versa. Integer cannot hold fraction numbers. Right? Let's make it 10.5. So let us print D now. Okay. If we want to sum these two, x plus D, let us see the output. It printed the literal values as it is. It has not done any summing. So let us use brackets. Here we got the sum of these two. This is automatic promotion of the data type. Here the x is elevated to double and the sum is performed. So let us say sum is x plus d. Let us say will it take. Let us use that sum. Let us print that sum here. So it gives an error of incompatible type. Here it's an integer plus double. It cannot return integer. So let us see. Let us make it double and see if it works. Yes. Here we have not used any casting. Here we have not used any casting to convert integer to double. That's an auto conversion. Okay. Let us define another variable, float f. So float, we need to use the word f at the end. Otherwise it gives an error of incompatible types. So double to float it doesn't accept. Let us compile this. Run. Yes, let us print f. Yes, it has printed the floating point value here. Double is double precision floating point, whereas float is single precision floating point. Where more precision is required, go for the double. Let us see if integer and float can be combined together. Printing sum again with integer plus float. Yes, we could sum these. Let us use some simple numbers. See, it is 3 plus 6.5 is 9.5. And the sum is of the double type. Let us define float. Yeah, the output is float. Let us sum integer, double and float into float. It gives an error of incompatible types. If we make sum as a double data type, let us see what it gives. Yes, it works. Right, the total is 3 plus 4.5 plus 6.5. Okay, more in the next session. Thanks for watching.